Today's Thursday, October 21st, and in today's class we talked about horizontal projectile motion. The key idea here to remember is that when an object is launched horizontally, you have two motions going on at the same time. On the one hand, you have a vertical motion, much like when you drop something, where the object moves further and further each second. And on the other hand, it's moving at a constant horizontal velocity. When you mix those two together, what you get is a parabola, or curvilinear motion is what the book calls it. We're going to use this idea to figure out the range of a projectile. So in class today we actually had this set up, but for now I'm just going to sketch it. So if I go ahead and I draw a projectile launcher, sort of like a little mini cannon, on the edge of a tabletop, it's going to project it for some distance, some range. It's going to shoot off like this. Now I'll tell you, when we fired this initially, it was launched from a height of 1.01 meters, so 101 centimeters. And it went a horizontal distance of 2.38 meters. We want to get the launch velocity, so to do that we need the horizontal distance and we need the time. Now we're going to use the same constant acceleration equations we've always been using, namely this one, d equals VIT plus 1/2 AT squared, and we're going to use it one direction at a time. Now what I like to do is I like to actually use blue for the y components and red for the x components. When students make mistakes with these kinds of problems, the mistake they make far and away the most is to mix up the x and the y components. So if we make the blue the y components and the red the x components, if you mix them together, that would make purple, and we don't want purple. So sometimes you hear me say no purple, or you've got purple in the brain. That means you're mixing x things and y things. For example, in the y direction, it is true that the acceleration, the acceleration is negative 9.8 meters per second squared. However, if I was talking about the x direction, the acceleration in the x direction is actually 0. It's not accelerating at all if we ignore air resistance, friction, drag. The velocity vertically we do know initially. That initial vertical velocity is 0. It's no different than if you dropped it. It just happens to simultaneously be moving in a horizontal direction at some velocity that we're trying to figure out. The one thing, however, that is exactly the same for both of these is the time. That's the thing that links the y and the x directions together. So first off, we want to figure out the time. So to do that, I'm going to use the vertical displacement, or the displacement in the y direction. Since we're taking a negative acceleration to be down, that means when I go down, it has to be a negative displacement, so negative 1.01 meters. The x direction, the distance there, is 2.38 meters. So the first thing I'm going to do is I'm going to try to find the y time, which is going to be the same as the x time. So let me just move this out of the way. So the equation we're going to use is the same one as before. D equals VIT plus 1/2 AT squared, keeping in mind we're doing this in the y direction, so some people like to put subscripts. Notice the t doesn't have a subscript because the t is the same in both directions. The other nice thing about this being horizontal projectile motion is that this will always be 0 if you launch it at 0 degrees horizontally. So you're left with this. So if I solve for t, you're going to get 2 dy over ay equals t squared, or t equals the square root of 2 dy over ay. I never give you that equation, but it is a useful thing to know. So if I plug in the numbers, so 2 times negative 1.01 meters over negative 9.8 meters per second squared, and we take the square root of that, that's going to give us a time that is 0.454 seconds. So that's going to give us the time. Now what we're going to do is we're actually going to figure out from that time the horizontal velocity. So if I could switch over to red, the horizontal velocity, because there's no acceleration, is just going to be the distance in the x, or the range, divided by the time. So this same time can now go in here. So that's going to give us 2.38 meters divided by the time, which is going to be 0.454 seconds, giving us a horizontal velocity that is 5.242. So 5.242 meters per second. So we were actually able to figure out the horizontal velocity just based on the time, or the height, and then we calculated the time, and the range that it went. In the next part of this problem, what we'll do is we'll use the same velocity and see what happens if I project it onto a lower height. For example, if I put a tin can, and see where that goes.